Hi everyone. Today's guest is Professor Hixuan Wu. He's an associate professor in the Department of Geography and Sustainability at the University of Tennessee, Knoxville. He's also an Amazon visiting academic and Google developer expert for the Earth Engine. His research interests include geospatial data science, remote sensing, and environmental modeling. So Professor Wu is particularly interested in utilizing big geospatial data and cloud computing, Google Earth Engine, Microsoft Planetary Computer, and Amazon Web Services to study environmental change, especially surface water and wetland inundation dynamics. His research has been funded by NASA. I think that's a success, and also the United States Department of Agriculture and Department of Defense. And Professor Wu is an advocate for open science and reproducible research, having developed and published various open source packages for advanced geospatial analysis. To the podcast, and thank you for being here, Professor Wu.
Thank you for the invitation.
Yes, so I will start immediately as we have the tight timing. And I recently watched your interview, and very interesting, amazing. I will also provide the link below the description. So, and based on that interview, it seems that your career path seems to have been shaped by two remarkable instances. Well, you can also say it as coincidence or twist of fate. First is your career choice, and second is making educational videos on YouTube that allowed you to make a significant contribution to open science and reproducible research. So could you reflect back once more and briefly share the story with our listeners of these two key instances?
Yeah, I think both of them are kind of by accident. So I didn't choose to study GS. I was assigned to actually study GS in college, and I end up like it very much. And then I finished my bachelor degree, then came to the US for graduate education, got my master and also PhD here in geography. And the second one is about making educational videos. It's kind of the side effects of COVID. So during the time, right, all the courses moved online, I think in 2020. So we all had to teach remotely. And I had to create those videos for my students. And I was thinking, maybe I can create something that both for my students, but also for the general public, because people might find it useful. Initially, I was very skeptical because I'm not native English speaker. So I kind of very shy that people going to pick me on your language, whatever. So it took me a while and also a lot of courage actually to post my first video. Actually, I had the YouTube channel for over 10 years, I think. But I've never really posted any video showing me speaking. Mostly just animation, like you record something, but I didn't really spend time actually try to record really professional videos. And it was by accident. So at the time I was teaching my student how to use Google Engine, and I had to record the video. So eventually I just create some short tutorial and post online. And so a lot of people are very interested in those, and then I continue to do it pretty much every week. So basically developing the software and then also creating short video tutorials at the same time, so that people know how this can be useful for their project and also for my students. And the rest is history. So I continue to do that, although I'm not producing videos every week right now, but I try to at least produce video at least a couple of those every month. And because I love learning new things, trying to incorporate some of the new things into the packages and teach people how it might be useful for them, teach people how to use. There are a lot of open source resources online and a lot of source code, but not everyone have the time and the skills to look into the source code to figure out how it might be useful for them. So I think there is educators or instructors or professors in academia, we should try to promote and then make sure people are aware of some of our efforts, rather than let people try to discover what you're doing. Unless you're someone really famous, sometimes it's just not you. We have to do the promotion actively so that people know what we're doing. Yeah. So those are kind of some of the backstories about why I was doing that.
Yeah, I love that part that you mentioned. As educator, we need to promote the science, not that others should come. We will come back to this part later on, but I think this is specifically interesting that, because you have thousands of followers and the information that you're providing is extremely useful. I've been following this, not this year, actually, a few years back during my master's. I have been already, I have seen some of your videos, not all of it, because it may seem like something that you've specifically focused and tried to record and promote yourself, but actually this is just a coincidence. Also, with looking at how much with passion you are doing this thing, I would like to mention one quote by one of my favorite astronomers, Neil deGrasse Tyson. Pick something you love and you will never work a day in your life. So do you agree with this statement? And what's your perspective on the role of passion and self-learning in academia?
Yeah, I sort of agree with this statement. I think it's very true. If you find something you really like, then you don't treat it really as something you have to, because I enjoy doing that. So I don't mind spending time during the weekend or at night doing things, software development or creating videos. None of those actually my job description at the university. I don't have to do that. But I think that it's really motivate me because you engage with the broader community and people find it useful. So your teaching basically have a large impact beyond the classroom. And that's why I think, especially for people, for example, in developing countries, a lot of those, the education level is really lower compared to here in the US or in developed countries. So not many people are aware of the technology. For example, how satellite imagery or AI or geospatial might be helpful for them to doing monitoring environmental changes or something like that. And also not many people in those areas have access to, for example, advanced computers or good configuration of computer data to do stuff. So, and there are a lot of freely available resources available right now, like provided by big tech or some organizations, NGOs. And so my goal is to basically promote this and make people aware of these resources, that they don't really need a degree to be able to do that. As long as they have some time, they have some patience, they want to learn, they can do it. And my goal is to make it easier for people to utilize this technology. And all you need is just some kind of internet access and maybe some account and then a browser, and that's it. You can start accessing tons of data, for example, from Google sending Microsoft Planetary Computer or NASA, ESA, all kind of agencies that provide this data. And they can use that to gain some insights and take actions. So I think it's very, very useful. So that's why I'm very passionate about basically education. Although I have my own research, but it's a very narrow area. Like not many people are doing the same research as you, but you are doing some general education that can have a larger audience. People might find it useful, and it's great to be able to teach and then make an impact on the society, and also make those tools that makes it easy for people to utilize.
Mm-hmm. I can completely understand you, and also this is something you are doing voluntarily, and I thank you from the large part of students' part, because this is invaluable. This kind of research, as you said, from developing countries, there are a lot of bright minds that people who don't have the needed education. So when they find your material, so there is a knowledge available, and then they can implement, and especially during this crisis time where we are facing a lot of I know in the US now it's happening, the wildfire in California. For example, this is one of the big examples. And these kind of situations are happening in remote parts of the world. And people with knowledge, with right knowledge and tools can provide a solution for this. Yeah.
Yeah, definitely. I'm also very fortunate that I have a job that allows me to do that. I just need to teach, and after that, I can do whatever resource that I want without having to like asking support from anybody else. So it's certainly this the freedom of doing research in academia, and also allows us to create contents and educate the general public.
That's good. Also, that's one of the interesting parts, because as I was preparing for this interview, it was interesting to see. Of course, I would be definitely lying if I say I went through all your materials. It's impossible. How did you learn yourself the coding? And you also wrote your own package in Python. You wrote your own book. So how did you come to learn this?
So I did learn like programming in college. I think at the time I learned like C, and then Visual Basic. And then when I came to the US, I also learned a little bit Python in graduate school, but it's like very basic one. And I think it really motivated me to learn Python is when I have to teach it. Then you really need to know it very, very well. So I think I spent a summer basically learning Python by myself, and then went through all the tutorial. I also like find videos online trying to learn and then read the books and then practice. But eventually you have to find some project that really can put them into practice, because you can learn all the basic, all the syntax. But if you don't really like practice it in real world examples, you might quickly forget all those things. So I teach my student, and then I start developing open source packages. It's because when I was doing my PhD, I used some open source package. I started using open source packages, and one of the notable one was the white box tools developed by Dr. John Lindsay in University of Guelph in Canada. I think around 2014, something like that, almost 10 years ago. So at the time, that was one of the major one that really influenced me, because it was open source. It has over like a couple hundred tools that's like freely available, and it's also the source code is also available, and it really helped me a lot. So, and then later on, I kind of built on top of the packages, the white box tools to provide packages, for example, for Python, for R, and also for Jupyter, and also for ArcGIS. So that's around, I think, 2015, 2016, maybe 2017. I forgot the exact number. But after that, I was still learning. Because there are a lot of geospatial packages. It's very diverse, because people can develop all kind of packages built on top of, for example, some of the most popular one. But it was not until 2018, 2019, I started learning Google Engine, the cloud computing, and it totally changed my kind of research, because you have to download data, and then you have to use desktop.js to process the data. But cloud computing allows you to actually process data at scale just using a browser, and you don't need to have a fancy computer. All you need is just an account, and then you can start doing all kind of computation. But at the time, it was like just JavaScript. There's not really a lot of Python tutorial for using that, and it took me a while to get used to it, because I'm not really good at JavaScript. I can write some basic syntax, but it never really learned all the advanced stuff. I'm more used to Python because I've used it, and also for teaching for a couple of years. So I started thinking about like, how do I make this easier? Because I went through the process to learn Google Engine using Python. It was not very easy. It's very difficult to even to visualize the data interactively. You can print out just a thumbnail, but you cannot visualize interactively. And for geospatial data, if you cannot zoom in and zoom out to see the details of data, it just lose all basically the benefit of using high resolution data. So I learned some open source packages, mapping, IPyLeaflet, Folium, and then just went down just like a rabbit hole, because there are a lot of packages that can help you visualize data and can also add interactive components into that. So it took me a couple months to basically learn some of those and then connect together. And then I started like releasing packages. Then a lot of people like interested, and then providing feedback and on GitHub. So it's like a lot of feedback from the community that basically motivate me to continue to develop, and also in the meantime creating tutorial, something like that. So it's just something, I think it's because of the side effects of a COVID is I had to do that. I have to teach, and in the meantime I had to do research, and I need to utilize those stuff. It was not easy. So kind of partly it's for myself, and partly for the students, and then it turned out that the geospatial community also could benefit from that, and the rest is just like history, because you can develop something that's being utilized by a lot of people. It also makes you feel that your work is useful, and you continue to motivate you to do and to contribute to the community.
Yeah, it's actually very interesting that you are saying that, if you cannot zoom in and zoom out, that's something we take for granted. I was running from some of your scripts and some of the mapping tools. We take it for granted, as it should be, but as you are telling the story that, you had to work on it to make it available. Yeah, it's a great effort. So, how do you think? So, what is the role of high spatial temporal resolution mapping on addressing climate change, and why it is essential to acquire skills on this area? Especially now, I think this question would make much more sense with recent incidents happening in US.
Yeah, certainly. I mean, remote sensing data becomes, like, in terms of spatial, spectral, and also temporal resolution, they become higher and higher. But also the data volume is increasing exponentially. And in terms of climate change, it depends on what kind of spatial and temporal scale that you are tackling. If you are doing like very long-term scale, global scale, you may not necessarily need very high spatial resolution data to do that, and it's very computationally intensive. So for weather and climate models, you don't necessarily need a very high resolution. But for disaster management, for urban planning, or some like very fine scale environmental monitoring, you do need this kind of high spatial temporal resolution data. And from like really available, for example, the Sentinel 1 and 2 data, 10-meter resolution, I think that's the base one freely available that we can utilize. And there's also daily, for example, 3 to 5 meter resolution from commercial companies, just like Planet, for example, and also Maxar, providing also sub-meter resolution, high resolution imagery for disaster management. And especially right now, for example, wildfire, earthquake, volcanic eruption, something like that. Those imagery are very, very important. And also in terms of migration, figuring out population dynamics, high resolution data, high spatial, temporal, and spectral data are very important. Also, if you're doing some, for example, ecology, it's also very important to have those high spectral data. So certainly, it's very important, and it's kind of essential skills that students need to have if they want to find a job that eventually tackling these kind of relevant issues using this, and also coupled with some of the machine learning, deep learning, AI stuff that's going right now. So, but I mean, besides processing data, the skills for processing data like this, and also important to have the background. So you do need to understand some of the basics about remote sensing, and otherwise you'll be just writing algorithms without having a deep understanding about why it appear like this way. For example, near infrared imagery, and why different types of features on the imagery show different color and different reflectance, and some of those terminology and thing is important to still to have, rather than just doing the data processing, become just a data scientist, because people from computer science, they can also, I mean, at the end, all the images is just numbers, right? It's just arrays or in the memory. But if you don't have a good understanding about what it is, you'll be just letting the computer drive you. So you do need to basically have a good understanding, and also with all the technical skills to be able to process data. So at the end, you can gain some insights and contribute to some of the open, for example, open source initiative, or some of the providing some open access data for the geospatial community.
Yeah, I do agree. I think this also makes sense because as I came to study, and also I know I work together with some people in data science, and in most of the time, what I see in environmental science, like, oh, we need to use this sophisticated model, or we need to use that sophisticated approach. But the whole point, if you don't have the basic understanding about the model, actually, and implementing it, you may how to say, you should know what model you are implementing and know about the model. And if this model can solve your problem, maybe there is a better model. So it's not just having the code and just running the code.
Yeah.
Yeah. Okay. Also, you mentioned that in, again, your recent interview, that you update your teaching materials every year to meet the current requirements, especially those of the job market. In your opinion, how important is adaptability in education, both for educators and students in today's fast transforming job market?
Yeah, it's certainly very important. You need to keep updated, learning new things. I think for me, the most important thing I learned in graduate school is not really learning any particular things. It's learning how to learn by yourself. Basically learning the capability. So if you're a fast learner, quick learner, you can learn things very quickly. You can easily adapt to whatever environment that you are in. So if you keep teaching the same materials every year, if it's always the same PowerPoint, then in nowadays you can become quickly very outdated. And in geospatial, especially if we're doing programming, I mean, there are new packages coming out every month, maybe every week, right? And some of the things that you used to do things very manually, now a lot of things can be automated. So if you are not really aware of what is going on right now, you are teaching skills to the student that are not very usable in their work environment or in the job market, then it's not very competitive. So that's why I always like keep on eyes on what's going on, what's the trend, what are some of the new technology that we can utilize, and then try to incorporate those into the teaching schedule and also the open source packages, so that we are always up to date. We might not, I mean, it might be difficult to always stay, I mean, in the latest, I mean, technology, but at least we should be somewhere in the middle. You don't want to still teach, for example, just using the desktop GIS and then just processing, for example, data at very local region. Because right now, with all the cloud computing and also AI, you can do things at scale, and things can change very, very quickly, and you can become very outdated just within a couple of years if you're not catching up. So certainly, I would strongly encourage either faculty or student to maybe just from time to time just look at what's the, for example, if you're doing programming, what are some of the most popular packages right now? What kind of things they can do? And think about incorporating maybe a couple of those into the teaching. And there are a lot of like things online, and especially with the generative AI, ChatGPT tools like that, pretty much you can learn anything. Just asking the AI ChatGPT to answer the questions, and also there are lots of tutorial people creating, and it's moving very, very quickly. So it's certainly something we have to keep an eye on. Otherwise, you might be asking the student, for example, you're teaching something that they can get all the information from ChatGPT. So why should they spend the money like to take your class, you certainly want to teach something that's not you can just simply just Google online, or you can find answers in ChatGPT. So you're teaching both the theory and also the engagement, and also something that help them think critically rather than just clicking buttons on the GUI and the software without really thinking like the theory behind why this behaving this, and so how to train them how to solve problem by themselves. Because once you graduate and then you become an employee for a company, you may not necessarily have someone there to help you all the time. So I think it's important for students to also learn the skills and learn how to solve the problem by themselves independently, rather than always rely on someone else. Of course, you can rely on some tools, ChatGPT and others, but still, they might not always give you the right answer. So you have to be able to distinguish what is a good answer, what is the not so good answer, and try to utilize all the resources available to help you solve real world problems.
I couldn't agree more. I agree with every sentence that you said, because I can provide maybe a real example. I know that big company CEOs tend to make big announcements. There were two instances when this made me personally worried. First, when first ChatGPT came out, after several months, that it could think like a PhD student and it could potentially replace a PhD. And therefore, I was, as a person who wants to further on, maybe be involved in academia, that I started thinking, okay, how this will transform academia. The second of all, I had a friend of mine who's a software engineer, and you know that recently Mark Zuckerberg made that big claim that they are already implementing AIs that could replace the software engineers. So when they make this kind of big claim, and I think this also puts a pressure to students like us who are actually just gaining new skills, and we are job market is changing very quickly. So yeah.
Yeah, certainly. It's the last couple of years, a lot of things has changed. So you do need to adapt to this, the job market, and also pay attention to what kind of skills are being required nowadays in those job descriptions, and try to prepare yourself for. If you need to apply, you need to check those boxes that people are asking for, but always try to learn something new every day, so that you are not replaceable by the AI.
Okay, that's a very good point. Yeah. So Google Earth Engine cloud computing, about maybe we can talk about it a bit. What is Google Earth Engine Explorer or code editor, Timelapse, and what are the potential implementations in academia, research in general? Also, what is GMAP or GMAP?
So Google Earth Engine is a cloud computing platform that created by Google initially in 2010. So it's almost 15 years now. And it was released to the public, I think, in 2014, 2015, 10 years before. And it's become very popular in the geospatial community because anyone can sign up an account for free, and they can use it for research and education, and also non-profit. It has a huge data catalog. So the Google Engine Explorer basically allows you to access data, visualize data interactively on the website, just you can search any data set. So traditionally, if you're doing remote sensing, we usually had to go to data portal, for example, NASA, ESA, whatever data portal, USGS, trying to download the data to your computer. They might provide a thumbnail for you to visualize, but there's not really a way for you to visualize any imagery, because there are petabyte data in the archive. So we had to download the data, and it takes time, it takes the bandwidth, and it's very slow, and you cannot really visualize data interactively. And it's Even if you can download the data, it's very difficult to actually process all the data, right? So you don't really have computer. One analogy I would give would be there are a lot of movies, right, created in the history of mankind. And so if you try right now trying to like, okay, I'm interested in watching a particular movie, you have to find where it, like for example, producer, which website I should go there. And then you have to download the, for example, the video to your computer. You have to need to have a decent computer to play the Blu-ray or the MKV file, and it might be many gigabytes. So it's this very inconvenient. But now imagine you can just go to, for example, Netflix or YouTube or whatever. You can just search, and then you can watch the video. You can fast forward. You can see everything, right? So that's what has already happened in, for example, in social the media and entertainment. But it's not in geospatial. We still have a lot of data sitting in the cloud, or in the physical server of those organizations. But not many people have resources to access those data. Even if you can access, you cannot really have enough computational resources to process the data. So this is where cloud computing, Google Sending, and also Plenty Computer or AWS, they can help you visualize the data. For Google Sending is the first one that's basically synthesize all the data and then make it in a standard format that allow people to quickly can basically source any geospatial data from any satellite for any location around the globe. Just with a couple lines of code, you can get the data and then can pull the data. You can visualize that in the, for example, the data explorer. So it's save a lot of time. So you can also see the data before you download the data. And they also have the code editor, allows you to write some JavaScript code to retrieve the data, process the data, and also export the data. So kind of like just like a coding environment allows you to do analytics and also do visualization. And the Timelapse is actually created actually before Google Sending, but it's like Google's used to have all those Timelapse like on their website. So those are basically creating global, for example, mosaic using Landsat or MODIS or other satellite, so they can quickly see the changes of any location around the globe using without having to write any line of code. It's very powerful, and it's especially useful for people not in the geospatial, but everyone can understand how things are changing on Earth's surface, because you can see deforestation, wildfire, urban growth, right? We can easily understand that. So time-lapse, I think, is a very powerful tool that can make people aware of what is happening on Earth's surface. And in geospatial community, people not only like just do the visualization, they also want to run analytics. For example, they want to analyze how the urban growth is happening, or deforestation, or vegetation changes, or sea surface temperature changes, or sea level rise, whatever things that people are studying. We have those data, but now you can use this kind of cloud computing environment to analyze the data at scale. So basically, it's up to imagination. All you need is just figure out what do I want to do, what kind of things you want to do. You don't have to worry about like how much data in there, and do I have the computational resources to handle it. Most like cloud computing right now nowadays can process those data at scale, and it's very efficient, because unlike traditionally desktop GIS, you have to download, for example, if you're trying to do a global, for example, forest change using Landsat data. Before cloud computing, you have to actually download all the images yourself. So think about the time it takes for you to filter the data to a certain cloud cover, and then doing all the mosaicing and then doing analysis for the entire globe. It's going to take a lot of data storage. And there's no way you can run the analysis just like one round using all the images, because it's just too much. But for cloud computing, you can do it easily just with a couple lines of code. So depends on the things you are studying. You don't necessarily need the native resolution. So you can just pull data at a global scale, and then the computation is being executed at your zoom level. So if you're just looking at global, you can just look at the kind of the big picture. You don't really need the details. Then the analysis doesn't have to be run at, for example, 30-meter resolution. It can be 3 kilometer. It can be 30 kilometer. It basically just resample. So when you zoom in, it becomes smaller. It gets a high resolution, but the area becomes smaller. So if you just want to try to show people your algorithm, how things are changing, you can run these things dynamically. So Google Engine or cloud computing, they handle that. So you don't really have to worry about the computation and the storage. And kind of like nowadays, you go to any website to find a video, watch a movie, right? You don't have to worry about how big is the movie, how big is the file, right? Under the hood, it's your purpose is to watch the movie. So you just click, you search, and then open it, and then it might buffer, depends on internet speed, it might buffer a little bit. But after that, you should be able to see exactly a certain timestamp of the movie that you want to watch, and you can fast forward, you can run analytics. So that's the whole idea of using cloud computing, is to that allows you to quickly access low geospatial data and run analysis at scale without just using a browser, without to worrying about your computation resources, or do I have the data storage for storing this data? Do I have the computation? All you need is just an internet browser, and then some kind of coding skills. Then you should be able to run those things easily using Google Engine or other type of cloud computing platforms.
I'm just so excited after this. I really want to. Actually, I want to provide for the listeners. They can find in the description some of the examples from your channel, YouTube channel. And in addition to that, what you said for the listeners, to make an example from my own research, for example, we used to be sometimes greedy. I'm downloading a lot. I want to download like for 4 years or for 5 years the Sentinel-2 image. Although there are filtering processes, I have to clean for the cloud, and there could be images where I just have a bare soil, but I'm interested in the vegetation. Therefore, I run first in the cloud when before downloading the image. I run all this filtering process, and then after I can download the images that have gone through this filtering process. So it's kind of saves a space, especially for you as well, because you don't have to then download the whole huge big data set, and then it takes, first of all, a lot of space, and then you don't know how to, this is what exactly you said, actually. Yeah. It's very, very powerful, especially in environmental science. Yeah. So we touched upon this topic a little bit, but perhaps we can stop it more. So how do you think the big data and AI are shaping the field of environmental science, and what new directions are emerging as a result?
Yeah, certainly I think AI is making an impact in all the disciplines, not just in geospatial. And certainly in geospatial, we see a lot of new initiative or big data, because the data volume is increasing exponentially. As I mentioned earlier, the spatial resolution is getting better and better. Just like, just think about the cell phone cameras, right? The quality of cameras has increases dramatically during the last decade or 2 decades, right? From the very early days of iPhone camera, now you rarely see people carrying like camera. Really, everyone's just using a phone, and the quality right now is getting close to a professional camera. So similarly, in geospatial, in satellite imaging, certainly the sensor is also in the quality is improving a lot. From Landsat to Sentinel, and also, for example, the Landsat Next going to be launched in 2030. So the resolution will be increased, for example, from 30-meter resolution to 10-meter or even higher. And also the spectral band is going to increase like more than double. So you'll be, for example, right now, 10 spectral bands. In the future, it'll be 26 to 30 spectral bands. So you can certainly see the volume going to increase exponentially, because 30-meter and 10-meter resolution, the file size will be increased 9 times, 3 by 3. And also the spectral bands are more than double. So you're thinking about the file size will be increasing 20 times, at least 20 to 30 times. So right now, one Landsat imagery is 1 gigabyte. In a couple of years, it will be 20 gigabyte. So think about how much data volume is increasing, and not many people have the resources actually to be able to download the data it's going to take you forever to download 20 gigabyte to your computer. And even if you can download it, I don't think the computer hardware will be that much improved. I mean, in a couple of years to be able to handle 20 gigabyte just for one imagery. Like if you're talking about like country and then national or global scale, it's going to be many, many terabyte. So it's certainly, I mean, the data volume is increasing. So that's the so-called big data. You need some kind of cloud computing to efficiently access and also process this data. And besides that, AI is going to play a major role in this geospatial environmental monitoring applications because with the data volume, there's no way you can manually, for example, doing land cover classification and then trying to do manually tracking, extracting the features. It's going to take forever. We don't have a lot of manpower to be able to do that manually. We certainly need some AI to help us, for example, extract building, for example, especially for wildfire happening right now in the US. So you can certainly see a lot more applications utilizing this high resolution, for example, Maxar area imagery, and also using AI deep learning to quickly extract the damaged buildings so they can compare them side by side and can quickly figure out how many buildings were destroyed and how many people were impacted. So without this, it's going to be very difficult to actually using the traditional way of downloading the data and then trying to process data manually because you just cannot catch up with all the data volume and also with all the AI because now we see the benefit because AI can quickly extract the building, for example, just within a couple of minutes. But if you're doing the manual delineation, it's going to take you hours or even days to do that for a large scale. So it's AI and all the like generative AI and also the deep learning algorithms are actually helping us quickly can process this kind of data at scale and then providing insights for environmental application. So yeah, to me, it's very important. So certainly for students want to, pursue a career in geospatial, it's certainly important to understand the data, how to analyze the data, how to present the data, and how to apply some of those latest algorithms or examples, and to quickly extract insights from the data rather than have to run things manually. It takes forever. It's not because it's especially for disaster. It's very time sensitive, so you do need to be able to act quickly. And if you need to act quickly, you need to have those information in your hands very quickly. So if you have the skills to be able to process those data quickly, then you are ahead of other people.
Yeah. So can we assume with our current development, AI and big data, that coding in Python or just in general coding would be one of the mandatory requirements in few decades?
Yeah, I think it's certainly, if you are trying to pursue a career in geospatial or GIS, I think certainly coding is now an essential skill. It may not be something like required, but think about if I'm trying to hire someone to do some GIS analyst tasks, and someone can have the coding skills to automate things. You're more competitive than other people that don't have. So I think it's certainly important for students or to learn at least one of language. To me, language is just a language. It's a tool that can help you do things. It doesn't have to be Python, but it can be R, it can be other language, whatever language, but try to learn one language very well. But Python is very easy to get started. And there are tons of resources. And also, especially with all the AI deep learning, most of those resources basically written in Python. So certainly Python is kind of a language that can easily pick up. So if you have time, I strongly encourage that students that learn, for example, Python. And now with all the online YouTube, ChatGPT, it's actually very easy. Even if you don't know, you can ask, and then you'll be able to actually quickly grasp those concepts or syntax, and then apply to real world problems. And I think the most important thing is to understand how to talk to a computer. To me, a specific language doesn't really matter. It's your computer thinking, how to think like a computer, how to subdivide a task into subtasks, and in each subtask, how to talk like a computer. Figure out how to formulate your questions that can be understood by the computer. And so that once you understand those concepts, then it's very easy. You can learn other language very, very quickly. So the more important is to learn those concepts about computer programming, and then just practice it using whatever language that you're comfortable with, and then deal with real world projects. Once you have done a couple of those, then you become very comfortable and you can easily pick up other languages because they all share a lot of similarities. The syntax might be different, but I mean, the core concepts are very much, I mean, they all share a lot of commonalities in different computer languages.
So it's just knowing how to talk with the, how to give the command, basically.
Yes.
Coding. Yeah.
Yeah.
Okay. Actually, thank you very much. I could keep asking many questions, but we have limited timing. I do have some general questions at the end, if you don't mind.
Oh, yeah.
Yeah. So again, coming back to my earlier question, maybe to add on, what skills do you believe are essential for incoming students entering career?
So for incoming students, you are applying for example, graduate school. I will certainly depends on whether you are applying for master program or PhD program. They might have different expectation, but in general, I think for students going for graduate school is important. A couple of skills I think important. First one is, for example, critical thinking. You do need to be able to think critically. I have supervised many students in the past, and some students can actually learn very quickly. So as I mentioned earlier, the most important thing I learned at graduate school is learn how to learn by yourself. So if you have that capability, you can quickly grasp the concept of any new things, and then you can quickly learn and then adapt. So critical thinking is, I think, one of the most important one that you need to understand. For example, at least basically, if you're doing research, you need to understand why I'm doing this, why this is useful, what's the impact, what's possible after you doing all this, right? So sometimes students tend to take commands from their professor. They don't really think why I'm doing this, right? Because if you're going for graduate school, you're not an undergraduate student. You are not just doing the lab assignments. Have all the detailed instruction given to you. You need to think independently and think about why I'm doing this. What can I do? How I'm going to do that? And what's going to become possible after doing this? So in order to do that, you also need to have some kind of research skills. You need to figure out how to, for example, do the source literature, write the literature review, and to synthesize what's the current status, right? So sometimes students tend to think like, oh, I'm very interested in this. And it's very broad. Like, I'm going to do GS in transportation. It's a very broad topic. You need to think about like what specific things in transportation you are going to do, what problem you're going to solve, what kind of skills you need to have. And you need to really narrow down your topic to something that's valuable and something that you can do, and also it's a valuable topic, rather than just, oh, I want to do this, but you don't do the homework. It's like it's already been done. 99% of the time, the topic that you are trying to do has been done. There are lots of applications. You just don't know it's already exists, right? And also try to ask GPT, for example, is this a valuable topic? Can you provide some references? Or who are the experts doing things in this area? So those skills are actually, I think, very important whenever student trying to start a new topic or applying for graduate school. If you have those, you're going to ahead of other students. They have no idea what they are going to do for their PhD. And another thing is time management. I think it's also something that most students struggle with is the good time management. You don't have a good time management, your energy will be spread it out to many things. And especially if you're doing, for example, teaching assistant or research assistant, and also you're taking all the courses, sometimes you might end up like not being able to actually do any research. So I would strongly encourage you to have a good time management plan and stick to it, and always try to learn something. I mean, especially in geospatial or GIS, try to learn something outside the classroom, something that can make your life easier, can make you increase your productivity, or learn some new skills or new packages or new tools or whatever that's not being taught in the classroom. Otherwise, everyone is learning the same things. You need to make sure that how you make yourself stand out, because otherwise you're not very competitive in the job market. So why should I hire you? And if you're just applying for graduate school, if you have the research skills, you have some publications, you're more than likely to be admitted compared to someone that without those skills. So to me, I think the combination of multiple things, you need to know the theory, know the background, and also have some technical skills. At least have something that can make yourself stand out, technically, or it's just something. Think about like how you make people remember you. What kind? You have to say one thing that basically give yourself an identity. What would that be?
Make a podcast.
Yeah, make a podcast, for example. Podcast. Yes, certainly a skill that not everyone has, and not everyone has that courage, right? So, for example, if I'm right now trying to tell people like, what do I do? Yeah, I do geospatial. I do open source. I create content. I'm kind of a YouTuber, not really YouTuber, but I do create YouTube video, right? So people know you through some of those things. So if you want to pursue a career in this, especially in academia, I think it's important to have some kind of identity. So when people talk about something, people quickly can relate your name to the things they are talking about. That means now people know your identity. Otherwise, you'll be right. There's so many people doing the same thing. Why you? Because you're not standing out compared to other your peers.
Yeah, I completely agree with your point. That's exactly how I also think, because actually, as the tools, our tools are advancing, every morning you will hear some news about AI doing some tasks that the tasks that you are doing can already be automated. So we have to stay competitive. I know that this is the timing, but this is the timing we are living. I completely agree. That's the same philosophy that I have. And I can maybe give an example as what you are saying, because I'm a PhD student. You've mentioned that, try to find something you don't know, but how? As an example, a few years ago, I had to learn, because I was very passionate to learn programming. I knew some part of it. I had to learn it from someone, but I didn't know how and when, because the courses that are being offered by the university were a bit advanced. So basically what I did is I was watching some YouTube videos, and I came to in Russian, of course, and then I came to know this one very nice channel in Russian, and I liked how he was explaining. So I reached out to this guy from Moscow, and I wrote him an email because he provided his email, and if he would teach me and I could pay, because Europe versus the ruble, it's higher. And during my master's, I could learn object-oriented programming. So during the weekends, this is something I did extra. No one asked me or anything, but once you have the passion, so you can just keep learning. I think this is an example. Yeah.
Yeah, exactly. So find something that you're passionate about, so that you're not forced to do. You will always strive to find time to learn those things that you want to learn. And right now, what I really want is to have 48 hours, so I can learn a lot of things that I want to learn. I have a long to-do list, a lot of things I want to learn, but I just don't have time to do all that. So but for students, I would encourage to do the same thing. Find something that you are passionate about. Something also might be useful, and something can also help you stand out among your peers.
Yeah. Also, in addition, I completely agree, because sometimes I miss my lunch, or sometimes I just sleep maybe less hours. But because when you are so passionate, you just you want to keep doing it. Yeah.
Exactly.
Yeah.
Yeah, to me, for example, coding is what I do when I'm relaxing.
Yeah.
When I have time, I will try to do it because it helps you think, help you formalize, and you are solving a problem. And once you solve it, it's like you feel very happy about that.
It's a meditation to your brain.
Yes.
That's how you meditate. Okay.
Yeah.
Also, in addition to, because for the listeners, maybe it might help even to add on your point. I think it's very crucial that what you mentioned, that you have to also find what you're passionate about. So that's why you have to keep learning different source and keep updating yourself. So looking up some extra things that might interest you. That's also, I think, you came to the GIS actually. You've been curious, learning and different source, and then you came to like it, right?
Yeah. Yeah, I think one important part is to stay engaged with the broader geospatial community, and also on social media, LinkedIn, Twitter, Facebook, whatever. I think I learned most of the new things from social media. It's people post about those things and I find it very interesting. I look into that, spend some time, learn something new, and then see if I can integrate into my packages or integrate into my research or teaching. So it's very important besides just like doing your own research, like just mind your own business. Sometimes you do have to pay attention to what is going on, what are people doing that, rather than reinvent the wheel, because things that you are doing might has already been done. So if you have time, do try to like from time to time bring yourself up to date and at least know what's going on, what's available, what if I want to do these things, what kind of things, what kind of tools or packages or software that can help me get the job done quickly.
Yeah, that again comes back to your, in addition to your point about the time management for the graduate students, because if they are aware of these new tools that are already available, someone has done their job. So it's about working smart. They can save their time as well, right?
Yeah.
Yeah. Okay. This is perhaps next very important for me question: how to keep curious?
Good question. Is keep learning. The more you learn, the more you feel that you know nothing. And then the more you feel curious, because sometimes, especially for geospatial, for coding, there are tons of resources out there. I don't know everything. There's no single person in geospatial that knows every packages, every tools. It's so diverse. Everyone can build something on top of that. So it's to stay curious, know what's going on, and then think about how can I utilize some of those things to solve real world problems. There are still a lot of things that happening around the globe that requires geospatial data and geospatial analysis. And how can we make it easier? For example, right now with all the disasters, how can we quickly gain insights? For example, how can we quickly detect all the buildings or trees or infrastructure, whatever, within minutes rather than hours, days, or months or weeks, right? There's always some room for improvement in terms of efficiency, speed, and also the time sensitivity, because it's very important, especially in this kind of disaster scenarios. There are a lot more, like even for something that's not really like in urgency, but if you know the way to improve it, you will always have a role to play in the community. You either do some insights or you can develop packages or whatever. So I think it's important to stay curious, to learn something new, and then to innovate, and then build something that other people can build on top. Not a destination. Rather than instead of a destination, it's a beginning for other people to build on top, and then to multiply the impact. So I think to me, how to really stay, curious is to learn and be engaged with the community, see what is going on, and figure out what might be useful, and be sensitive to some of the latest tools or the software or whatever or anything like can improve your productivity or in general can help us do things much more quickly and better, more effective and more efficient.
Yeah, that also benefits the society at large and provides solutions. Yeah. To summarize, what advice would you give to your younger self, and any advice for incoming PhD students or master students?
Yeah, for myself, I think certainly if you are pursuing a career in geospatial and going for graduate school, I think it depends on which way you want to go. If you go to the academia or going to industry or non-profit, whatever, there might be different type of advice I'll give. But in general, I think in geospatial, I will encourage students to stay current of what is going on, what are the latest tools. But also, it's important to learn some of the serious concepts that's very important in geospatial. Otherwise, if just simply just doing coding, how do you distinguish yourself from people from computer science? So you do need to have some kind of geospatial background, interpreting the set imagery or whatever. That's something that computer science people don't know. Otherwise, you cannot compete. If you like people start trying to hire somebody that can do coding, they will not really hire people from geography. They hire people from engineering, from computer science. So you need to have something that make yourself distinguishable from other disciplines. So I think in geospatial, it's kind of combination of geography and also computer science. So you do need to enhance both of those, your coding skills, but also your theoretical foundation about remote sensing GIS and also geospatial. And in that way, you can provide some insights that other disciplines that they don't have. And so this is just like on the technical perspective. But if you're trying to have a career in academia, you need to do research. You need to write papers. You need to apply for grants to support your research, to support students. So you do need to learn how to write papers, how to conceptualize your research question, how to formalize discussion, and how to use your technical skills to help you conduct all the analysis and how to present and how to have that kind of critical thinking. Rather than just clicking the button, running the source code, you need to think a little bit more behind those source codes, answering the questions, why it is important, why it is valuable, why I'm doing this. Who cares? Why do we care about what you are doing? So you need to actually to have very strong arguments about what you are doing. And then you need to document the things that you are doing and then write the manuscript, the paper, publication, all that. But if you're just going for the industry, then I think sometimes the paper doesn't really matter that much. It's more about your technical skills. What kind of things you can do? What kind of project have you done? And how to showcase yourself. So I think it's important to have some footprints on the internet, either your GitHub, your social media, whatever. There's some kind of connection or something that can showcase what kind of things you can do. Some of the projects, or maybe have a website demonstrating your project or something like that. And if you're just applying for graduate school, I think is you make sure you do well in all your courses, right? Try to have a good GPA and then try to have some publication if you can. That's going to really help you in the application and also have a lot of projects, a lot of skills, and also communication, how to communicate with your professors, how to write, and how to really distinguish yourself from other people and distinguish yourself from AI. I think with the last couple of years, I've received a lot of emails that you can clearly see that it's written by AI. It's not something that very authentic. So you do need to really read and think about, is this, if I'm trying to send this email to a professor, what they are going to think? How do I write in a formal way that's also not, I can certainly use AI to help you improve, but you also need to make sure that it's coming from you, because everyone is writing in a different pattern. So you don't want to totally like writing in just like a voice of AI. Then you're not going to be very able to be considered by the professor. So a lot of things that, I mean, certainly different people have different perspectives. So, but I think it's important that you have the technical skills, you have your research skills, and also your communication, and also try to, I mean, be connected with the community, know what's going on. And if you know some people, sometimes it's easy to get some recommendation to get into a particular graduate program, and go to the conferences, professional conferences, get connected with your prospective professor, and then you can, I mean, engage with them on GitHub, on social media, make some connection. You never know. Sometimes it's just the connection that can get you the ticket into a program.
Yeah, completely agree. I think you outlined all the important points that is necessary. Everyone who is listening to this podcast, I think it's definitely very useful, especially for me. I've now much more motivated, inspired, and then now I'm going to, just after recording the podcast, start my. I was working on a model.
The podcast was certainly your one of your identity, right? It's not. I mean, when I was doing my PhD, and there's no way I could find time to do a podcast. Like try to devote the time every week, every month to doing something like this. It takes time to, I mean, coordinate all this, and also to talk to people, and then do all the editing. It's a lot of time, because I've done a lot of YouTube videos, so I know how time consuming it is. So for me, I just like work on my own. So I can get things done very quickly. But whenever you like have a big team, sometimes it's just like you need to find a way to work with people. So I mean, teamwork is also very important. But sometimes you just don't have time for that. So, but I mean, for graduate students, I think it's important to have lots essential skills that can make sure that you stand out in the job market.
Yeah, I completely agree. And also making a podcast, I'm very much lucky that most of the times I have my partner who is helping me while I'm focusing on my PhD. He helps me to take care of some of the parts, arranging and everything. Doing the research, background research, and we did run this together actually. As for the purpose of doing this podcast, it's essentially why I completely agree with your perspective, because that's also how I think it's keeping updated myself. Because talking with the researchers, I have an interesting idea, and that questions that I would like to ask this researchers, and then they can outline some of the ongoing new approaches, and that will also help me to update my own work, because maybe I'm using something outdated. So yeah, it comes back again to your point. So thank you very much for this amazing for your time, for sharing your experience, for sharing with really valid points for academia, for industry, for both making attention. And also you will find all the social media platforms of Professor Wu in the description, and also some of his YouTube channel and some of his publications as well. And thank you very much.
Thank you very much, Nas. It's great talking to you and sharing some of my personal experiences. Thank you.
Thank you.